We're going to start today's class by going over the last two examples from the video. These are on page 13 in your note packet. So if you did them, great, follow along with me. If you didn't do these problems, please make sure that you write down the work as I go through them right now. So in extra example number 1, it says the following triangles are similar. You have to find the ratio of the perimeters and the ratio of the areas. Now, both the ratio of the perimeters and the ratio of the areas is related to the ratio of the sides. So the first thing that you should have done is found the ratio of the sides. To do that, you need to find the sides that are corresponding. So on our first triangle, we have sides of 10 and 12. Now, 10 is the smaller side, so as Mrs. Pugalko said in the video, that's going to correspond to the smaller side on the second triangle. So I get 10 over 15. 12, which is the larger side, is going to correspond to 20 on the second triangle because that is the larger side. Now, as Mrs. Pugalko reminded you, these are not reduced, so you need to reduce them. That 10 over 15 reduces to 2 over 3. That 12 over 20 reduces to 3/5. Now, as you can see, we have an issue here. We don't have the same scale factors. So this problem really is not possible with the information that I have given you. Now, if we ignore the 12 over 20 and we stick to the 2/3, if that is the ratio of our sides, then the ratio of the perimeters is also 2/3. And then the perimeter, or the ratio of the areas, is the 2/3 squared, which would be 4 to 9. The problems that you're doing in your classwork today, you're not going to have an issue like this. But in this case, we just have to ignore one of the scale factors. So I'm sorry that we gave you one problem that wasn't possible. Now, problem number 2, though, is possible. It says pentagon 1 and 2 are similar. The side length of pentagon 1 is 3. The side length of pentagon 2 is 5 inches. Show the steps you would use to find the area of pentagon 2, given that pentagon 1 has an area of 18 inches squared. Okay, so the first thing that you should have done is noted the ratio of the sides. Now, we are told that our figures are similar. We have a side length of 3 and a side length of 5. So if I'm doing pentagon 1 to pentagon 2, that's going to be 3 to 5. Now I'm asked to find the area. So next I need to find the ratio of the areas. Now you need to remember that the ratio of the sides squared is going to give us the ratio of the areas. So the ratio of the areas is not 3 to 5. Instead, I take that 3 to 5 and I square it, which means that the ratio of the areas is 9 to 25. Again, this is pentagon 1 to pentagon 2. Thirdly, I need to set up a proportion. So I'm going to change that 9 to 25 to look like a fraction. Again, this is pentagon 1 over pentagon 2. Now I know that the area of pentagon 1 is 18. Now, pentagon 1 is in the numerator, so I'm going to put an 18 here. I'm looking for the area of pentagon 2. So at this point, you're going to do cross products and solve for x. 9 times x is 9x. 18 times 25 is 450. If I divide both sides by 9, I get x to be 50. So this means that the area of pentagon 2 is 50 inches squared. Again, inches squared because it's area. Now hopefully you got those right. If not, that's okay. You will have more practice in today's classwork. Right now, you are going to start working on the classwork for day 3, so section 11.3. For the harder problems, or the ones I think that you might get stuck on, there are some video hints that are on Schoology that you can look at. I will check everything in on Wednesday when you come back. Good luck!